There isn't much that I feel I need. A silent soul and I know I'll be with the little girl and my lifestyles. I only want a proper house. There isn't much that I feel I need.
Section 1.3 is on simplifying radicals, and we did this last year, so it's kind of review, although we're going to take it to a more difficult level this year. So first of all, two reminders of some laws to do with radicals. If you're taking the nth root of a product, a times b, that's the same as taking the nth root of a and multiplying that by the nth root of b. So to exemplify that, if I was wanting to know what the square root of 4 times 9, one way I could do it is I could actually multiply 4 times 9 and I get 36. And then I know that the square root of 36 is 6. Okay, no problem. But there's another way we could solve this. We could use this property right here. The square root of 4 times 9 is the same as the square root of 4 times the square root of 9. What's the square root of 4? 2. What's the square root of 9? 3. We're going to multiply those together and we get 6. We got the same answer in each case. Okay, the second property here, if you're taking the nth root of a fraction, then that's the same as taking the nth root of a and dividing it, I'll write the division like this, by the nth root of b. Okay, it's very similar to this, right? You're just separating the two parts. In this case, you're multiplying the two parts. In this case, you're dividing. So we'll show you an example of that. If we had the cube root of 64 over 8, one way you could do it is to take the cube root of 64 divided by 8 is 8, and the cube root of 8 is 2. But another way you could do that, I'll write the same question here, is you could take the cube root of 64 and divide it by the cube root of 8. That's supposed to be an index, it's way too big. So the cube root of 64 is 4, and the cube root of 8 is 2, and 4 divided by 2 is 2, and we get the same answer again. So these are important properties to know, and you're going to use them a little bit in today's work. Alright, here we go, simplifying radical expressions. So to simplify radical expressions, what we mean is you're going to turn an entire radical, like this one, everything's inside the radical sign, you're going to turn it into a mixed radical. You're going to get as much out front in the coefficient position, as much in front of the radical sign as possible. And the way we did this last year, for most of you the way you did it, is you made a tree, right? And you asked yourself, what's two numbers that multiply together to get 40? And there's a bunch of different options, 2 and 20, 4 and 10, 5 and 8. I'll do 4 and 10, but you can do whichever one you want. 4 is the same as 2 and 2, 10 is the same as 2 and 5. So another way you could write the square root of 40, it's the square root of 2 times 2 times 2 times 5, right? 2 times 2 times 2 times 5 equals 40. This is the prime factorization of 40. These are all prime numbers here, and you multiply them together to get 40. Now, because there's a little index here you can't see, but it's a little 2, that means we're looking for pairs, just like we did last day though. So I look for a pair and I get a pair there, and that's not a pair, it's not the same number. So that's it. So what happens with the pair is that number comes out front. So you have a 2 out front. These numbers are stuck inside the radical. They have no pair. You can't come out unless it's in a pair. So these guys are stuck inside. And what you're left with is a 2 times 5, which equals 10. Okay, they're going to be all very similar to this. So 72 is our number. Ignore the negative for a second. So 72. I'll do 9 and 8. And then that becomes 3 and 3. And that becomes 2 and 4, and then the 4 becomes 2 and 2. Okay, so the cube root of negative 72 is the same as the cube root of negative 2 times 2 times 2 times 3 times 3. Again, I just picked all the prime factors, right? 3, 3, 2, 2, 2 are all the prime factors. Okay, there's an index of 3 here, so we're looking for a triple. Not a pair this time, but we're looking for a group of 3. And there is a group of 3. There's a group of 3 right here. So we know that we're definitely going to have a 2 come out front. And we're going to have the same cube root here. But what are we going to do with this negative here? Well, if you take the cube root of a negative, what kind of answer are you going to get? Negative. A negative times a negative times a negative is a negative. So I think the easiest way to deal with this, and what your book does, I'm pretty sure, is they just move the negative out front, because you know your answer is going to be a negative. So you put your negative out front. Okay, so what we're left with, since we brought the negative out and we brought these 2's out, we're just left with 3 times 3. And 3 times 3 is 9. So there's our answer. I don't think I need to put that so big. We're done. Alright, continuing on, you'll see this one, we have some x's and y's. So, first of all, I'm just going to worry about the number, 120, and I'm going to make my tree. So, how about 40 and 3, or 3 and 40? And then I'll do 2 and 20, and then 2 and 10, and then 2 and 5. Okay, so 120 x to the 5th y squared is the same as 2 times 2 times 2 times 3 times 5 times 5x's, x times x times x times x times x. Remember we did this sort of thing last day, times y times y. Wow. And we are looking for pairs because this is a square root. So there's a pair here of 2's, no pairs. Here's a pair, here's a pair, and here's a pair. Alright, now before we do anything else, in fact I probably should have done this before, as soon as you have x's and y's, you need to worry about whether you need restrictions or not. So this is a square root. What do you know about the amount inside here? It can't be negative. So do you need to restrict either the x or the y? Yes. Which one? Just the x. The x because it's an odd exponent. So if the x was negative, it wouldn't work. You'd end up with a negative amount in here. So you need to have a restriction that x is greater than or equal to 0. Do you need the restriction like that for y? No, you don't. Because y is squared, it's to an even exponent, and so even if y is negative, it's going to end up being positive in here when you square it. This is just from last day, right? Okay, so let's look at what we have. We have a pair coming out, which is a 2. We have an x and another x, so that's an x squared, and we have a y coming out. And then what's left inside is 2 times 3 times 5, which is 30, and we still have one x left. And then we have our restriction, the x is greater than or equal to 0. But be careful, now you need to look at the stuff out front here. Do you need to worry about putting absolute value signs on those? Well, you certainly don't need to with the x for 2 reasons. One, because you're squaring it, so even if it was negative, it's going to become positive when you square. And the second reason you don't have to worry about it is because you've already restricted it. You've already said it can't be negative, so definitely you don't need to worry about absolute value signs on the x. How about on the y? Yes, you do, because we said y could be negative here. Once you square it, it'll become a positive. But if y was negative, you'd end up with a negative amount out front, and you can't take the square root of something and get a negative amount. So you're going to have to put that in absolute value signs. Okay, last one. So we have the cube root of x to the 15 over 27. So I think this is a case where maybe I'll use this rule up here where I'll split it. So I'm going to end up with the cube root of x to the 15 over the cube root of 27. Okay, I do not want to write x times x times x times x times x 15 times. But since we're looking for groups of 3, how many groups of 3 can we get in the 15? We can get 5. So it should be x to the 5th divided by the cube root of 27 is 3. There you go. Now, I should have at the start mentioned, do I need to make restrictions here? It looks like you might because we have an odd exponent here. And that could make this this inside part negative. But you don't need restrictions here. How come? Because there's an odd index. If there's an odd index, it's awesome. You don't have to worry about restrictions and you don't have to worry about absolute values because you're allowed to have negative. You can have a negative amount inside here if it's an odd index. So I'm going to put no restrictions needed when the index is odd. Okay, so it's quite a relief when you see that your index is odd. Page 2. Now we're going to do the opposite. We have mixed radicals here because we have some coefficients and some radicands, and we're going to turn them into entire radicals. We're going to move this outside part inside the radical. So this is your club. Remember the club 3 and club 2 and all that kind of stuff? Well, that's what's happening here. If you need to get this 3 into the club, what's the name of the club first of all? Well, the index names the club. So it's club 3, and this 3 is going to come into the club, but he's just a guest. So he's got to pick up his badge, which is the 3, right? So it's 3 cubed. Now, this 2 is already in the club, so he doesn't need to pick up a badge. Why not? Because he's a VIP, baby. I write that for my kids who graduated last year who just love this. We would say it over and over and over again. Anyway, yeah, so there you go. If you do this, you'll have your answer. Now, that's kind of a cheesy story way to do it. Of course, the reason mathematically this works is because we're doing the opposite of what we did in the last page. Remember, in this one, for example, in order to take out 2's, we had to get a group of 3. Since it was a cube root, we had to get a group of 3. So if we're going the other way and we have a group of 3, we have to have 3 to bring it in. So you have put 3 of them when you bring it in. I hope that didn't confuse you even more. Anyway, what we end up with is the cube root. Don't forget, you always have to have the same index through all these questions. 3 cubed is 27 times 2 is 54. Okay, here's your guest that wants into the club. And the club is called club what? Club 2, because there's no index there, so there's actually a little 2 there. So in club 2 we have 3x squared, but it's got to pick up its badge, and the badge was the 2. But the VIP, baby, is the 4x5. So we just have to solve this and we're done. Now, to solve this, you have to spread the love. So 3 squared is 9, and x squared squared, do you know what you do with those? You multiply, so you get x to the 4th, and then we're going to multiply all that by 4x to the 5th. Okay, to multiply polynomials, monomials in this case, you just multiply the coefficients together. 9 times 4 is 36. Multiply the powers together, x to the 4th and x to the 5th. And the rule for that, as I'm hoping you've memorized, is you add the exponents. The base stays the same, and you add the exponents, and you get a 9. And we're done. Okay, the next one is a club 3 again. So inside the club, we're going to bring in, wait a minute, we're going to bring the negative in? You can bring the negative in. That's fine, because you're allowed to have a negative radicand when there's an odd index. But I think what your book does is it just leaves the negative out front. So we'll do that. We'll just leave the negative out front. But in this case, you could take the negative in as well. And so what we're going to bring in is the 2xy squared, and it has to pick up its badge, the 3. And inside is the 5x squared y to the 4th. It doesn't need a badge because it's the VIP. So, got to do some spreading the love here. 3 places you got to spread the love. So what you end up with is negative 2 cubed, that's 2 times 2 times 2 is 8. X cubed is x cubed. And y squared cubed, you're going to multiply that, so you get y to the 6th. You're going to multiply that by 5x squared y to the 4th. So you end up with negative 8 times 5 is 40. X cubed times x squared, we're going to add those exponents and get x to the 5th. And y to the 6th times y to the 4th, we're going to add those exponents and get y to the 10th. So there is your answer. And you know what I've missed? Anyone catch it? I missed all my indices. There has to be a little 3 on all of those ones to show it's a cube root. Did I miss it anywhere else? No, I think I'm good. If you wanted to, you could have this negative inside as well, and that would be totally acceptable. However, in the next question, there's also a negative. You cannot bring that negative inside. How come? Because if you bring that negative inside, your final answer is going to end up being something that has a negative inside a square root. And you can't do that. You can't have a negative inside a square root because you can't take the square root of a negative number. So what you have to do in this case is you must leave the negative out front. That is essential. So why don't you just get in the habit of always leaving the negative out front, and then you'll never have problems with this. Anyway, what you'll do is you'll bring all this x squared y over 4, you're going to bring all that in to the club. But that's got to pick up a badge. What's its badge? Well, this is club 2. And the VIP is the 3xy squared. It was already in there. Okay, spread the love 3 times. 1, 2, and down there as well. So you end up with negative square root of x squared squared is x to the 4th. Y squared is y squared. And 4 squared is 16. And we're multiplying that by 3xy squared. Okay, negative. Let's look at our numbers. We have a 3 on top and a 16 on the bottom. We can't simplify those. If we think of that as a fraction, you can't put it in lowest terms or anything. It's already in lowest terms, so we just keep it just like that. Also on top, we have some x's. We have 4 here and 1 there. We're multiplying. X to the 4th times x to the 1st is x to the 5th. And y squared times y squared is y to the 4th. And we're good. Negative must be outside. Okay, these last questions, we have to say which one's bigger, which one's smaller. So, cube root of 60 or cube root of 71, which one's bigger? Well, this one's bigger. Has the same index, and have a bigger radicand. If you think of it, the cube root of 60 has to be somewhere, what's 4 times 4 times 4? 4 times 4 times 4 is 64. So the cube root of 60 is less than 4. The cube root of 71 is more than 4. So this is definitely the bigger number. The 4th root of 23 or the 5th root of 23? So the 4th root of 23 means a number you multiply by itself 4 times to get 23. The 5th root of 23 means a number you multiply 5 times to get 23. Which one's smaller? Let's just start with that. Which one's smaller? If you have to multiply a number 4 times to get 23 or multiply it 5 times? This is smaller. You have to multiply it an extra time. So this one's bigger. You should go like that. Okay, this one, they have the same index of 2, but they've got these are mixed radicals. It's really hard to figure out what to do. So you know what you do? Change them into entire radicals. Bring this into the club. So you're going to end up with 3 squared, picks up his badge, and 4 is the VIP. 3 squared is 9 times 4 is 36, square root of 36. On this side, bring 2 into the club, so you get 2 squared times the 10, which is already in there. That's the square root of 40. What's bigger, square root of 36 or square root of 40? Bigger radicand is that one. And the last one. Careful, we're negatives here, so I'll leave the negative outside and bring the 2 into the club. So I'm going to end up with, maybe I'll do this in a single step, save some time. You bring the 2 in and cube it, so that's 2 cubed is 8 times 5 is 40. For this one, leave the negative outside, cube root of, bring 3 in and cube it, 3 times 3 times 3 is 27, multiply it by 2 is 54. Now be careful, which one's bigger? Think of a number line, here's 0, here's negative 40, here's negative 54, this is bigger, right? It's kind of opposites when you're looking at the negative numbers. A smaller negative is actually a bigger number. A bigger negative, like 54, is a smaller number. You know that. I don't need to go into such detail. Okay, that's the end of this lesson. I hope you found it a little bit easier than the last one.